Welcome back students to this class of mathematics. As you know, we are discussing the syllabus of class 12th mathematics here, and we are in continuation of chapter 3 matrices. And yesterday I did a few questions of exercise 3.2. Today I am going to do question 18 and question 21 of exercise 3.2, and in this video you will also see that we are going to discuss transpose of a matrix, symmetric and skew symmetric matrices, theorem 1 and theorem 2 based on this matrix. Question 18, exercise 3.2. Given a matrix A 0 minus tan alpha by 2, tan alpha by 2 0, and I is identity matrix of order 2. So we have to show that I plus A is equal to I minus A into cos alpha minus sin alpha, cos alpha. Let us proceed to solve this, and let us first calculate LHS, which is I plus A. So I is the identity matrix, A is the given matrix, this matrix. Now I add the two matrices. After adding these two matrices, I get 1 plus 0, 0 minus tan alpha by 2, 0 plus tan alpha by 2 and 1 plus 0. And right hand side is I minus A, cos alpha minus sin alpha, cos alpha. So I substitute the value of I, which is 1001. I substitute the value of A, which is given to you. So I have to subtract A from I, and whatever the result will be, it is to be multiplied with this matrix. So I subtract these two matrices, 1 minus 0, 0 minus tan alpha by 2, which gives you plus tan alpha by 2, 0 minus tan alpha by 2 and 1 minus 0. So the resultant of these two matrices is this matrix, and then we have the second matrix, and now we are going to multiply these two matrices. Now we multiply these two. This is the RHS that we are calculating. So first row of my first matrix with first column of this matrix. So 1 into cos alpha plus tan alpha by 2 into sin alpha. Now for this element we must multiply the first row with the second column, 1 into minus sin alpha plus tan alpha by 2 into cos alpha. Now for this element we multiply the second row of this matrix with first column. So minus tan alpha by 2 into cos alpha, minus tan alpha by 2 into cos alpha plus 1 into sin alpha. So plus sin alpha. Now for A22 we multiply this second row with second column. So minus tan alpha by 2 into minus sin alpha gives you plus sin alpha into tan alpha by 2 plus cos alpha plus 1 into cos alpha. Now students, we can call this matrix as A11, A12, A21 and A22. We observe one more thing. Please observe that this element A11, which is same as the element A22. So here we observe two things. A11 is equal to A22. This we are observing for calculation purposes. And second thing that we observe is that these two elements A12 and A21, they are negative of each other. So we also observe that A12 is negative of A21. So this will help us in this way that out of these four elements A11, 12, 21 and 22, we shall be calculating only two elements, and rest of the two elements values we will be getting with the help of the other two elements. So first of all I am going to calculate A11. We call this equation as equation number 1. and our job is to find the values of A11, 12, 21 and 22 and substitute it back in this equation. So students, I write the element A11. As you can see, these two matrices, A11 is cos alpha plus tan alpha by 2 plus sin alpha. So I know the half angle formulas in class 11th. We have studied them. Cos alpha can be written as 1 minus 2 sin square alpha by 2 plus tan alpha by 2 can be written as sin alpha by 2 upon cos alpha by 2, and sin alpha can be written as 2 sin alpha by 2 into cos alpha by 2. Now we also observe that cos alpha by 2 and this cos alpha by 2, they get cancelled. So we get 1 minus 2 sin square alpha by 2 plus, we multiply sin alpha by 2 with 2 sin alpha by 2. So we get 2 sin square alpha by 2. So again we observe that these two elements also get cancelled and the result is 1. So we have observed that element A11 has come out to be 1. Now, as we have already written that A11 is equal to A22. So this implies that element A22 is also 1. So I have got the value of A11 is 1, A22 is 1. Now I will calculate the values of A12 and A21. Now A12, element A12 is minus sin alpha plus tan alpha by 2 into cos alpha. Now we calculate. Again we are going to use the half angle formulas. So according to the half angle formulas, cos alpha can be written as 2 cos square alpha by 2 minus 1. Then we multiply and we get minus sin alpha plus tan alpha by 2 into 2 cos square alpha by 2 minus tan alpha by 2. We have multiplied tan alpha by 2 with this bracket. Now again we move further and we write this tan alpha by 2 as sin alpha by 2 upon cos alpha by 2 into 2 cos square alpha by 2 minus tan alpha by 2, and we observe that cos alpha by 2, it cancels 1 power of cos square alpha by 2. Then we calculate further and we get minus sin alpha plus 2 sin alpha by 2 into cos alpha by 2 minus tan alpha by 2. 2 sin alpha by 2 cos alpha by 2, and this is nothing but sin alpha. So we get minus sin alpha plus sin alpha minus tan alpha by 2, as this is the half angle formula of sin alpha. So now we see sin alpha and minus sin alpha by 2, they again get cancelled and we get the result of A12 as minus tan alpha by 2. Now we already know that A12 is equal to minus of A21. So we get that the value of A21 should be negative of the value of A12, that is negative of negative tan alpha by 2. So we get the value of A21 to be tan alpha by 2. So now we substitute all the values of A11, A12, A21 and A22 in equation 1. So we substitute, we write equation 1, which is this, that is RHS, and we substitute the values of A11, A12, A21 and A22. Then we had already calculated LHS, which was also the same, and hence we have proved whatever was asked. Now students, we are going to discuss now question 21 of exercise 3.2. Here you are given 4 matrices X, Y, Z, W and P. These are 5 matrices and their orders are given. The order of x is 2 cross n, order of y is 3 cross k, z 2 cross p, w n cross 3 and p is p cross k. Now question is that if this operation is defined on the matrices py plus wy, so this operation will be defined, then what is the restriction on these orders? So first of all we have to check when py will be defined. P is a matrix of order p cross k, so I write it here. Y is a matrix of order 3 cross k. So students, tell me when py will be defined. Py will be defined when number of columns of p, that is k, is equal to number of rows of y, that is 3. So it gives us k should be equal to 3. So one result that I get from here is k should be equal to 3. Then I have to see when wy is defined. So I write w whose order is n cross 3. I write y whose order is 3 cross k. Now this product wy will be defined if number of columns of w is equal to number of rows of y, which is already there. 3 is already there. So now the order of py plus wy should be same, then only py and wy sum will be defined. Py will be defined when k is 3, wy is already defined, but their sum, the sum of py and wy will be defined if the order of py will be equal to the order of wy. So let us see what is the order of py. The order of py will be p cross k. So order of py will be p cross k and order of wy will be n cross k. So that means p cross k should be equal to n cross k. This implies that p should be equal to n. So we have got two results from this discussion. One is that p should be equal to n and the second is that k should be equal to 3. Now if we combine these two results, then we get correct option to be option A. It is a MCQ in the exercise and 4 options are given. Option A gives you that k should be 3, p equal to n. So you have found k to be 3 and p equal to n. So the correct option is option A. Next topic is transpose of a matrix. So what do we mean by the transpose of a matrix? Consider a matrix A which is equal to aij m cross n. Then transpose of the matrix A is denoted by A dash or writing a capital T in the superscript AT. So transpose of A or AT is nothing but AJI. That means the element Aij has been interchanged with the element AJI. What does it mean? It means that matrix A transpose is obtained by interchanging rows and columns of A. That means the rows of A have become the columns of A now in A transpose and columns of A have become rows in A transpose and the order also changes. If the order of A was m cross n, then the order of A transpose will also reverse, it will become n cross m. That means rows have changed into columns and columns have changed into rows. Let us discuss one example. Consider this matrix A which is a 3 cross 2 matrix. You can see it has got 3 rows and 2 columns, 3, 7, root 2, 1, minus 1, 1 by 3. Then now let us see how shall we write A transpose. To write A transpose, I will read the first row and convert it in a column. First row is 3, 7 here. In transpose, it will become first column. Second row is root 2, 1 in A and in A transpose it becomes second column. Root 2, 1. Third row is minus 1, 1 by 3 in A. In A transpose it becomes third column, that is minus 1 and 1 upon 3. So now you must have learned how to write A transpose by A. You read a row and you write it in a column. Read another row, write it in another column, another row, another column. Now the order of the given matrix A was 3 by 2. So the order of obtained matrix after taking the transpose becomes reverse, that is 2 by 3. Now after this we are going to discuss some properties of transpose. So what are the properties of transpose of a matrix? Suppose A and B are any two matrices of suitable orders. Then we observe that if we take transpose of A transpose, that is 2 times if we take the transpose of a matrix, we obtain the same matrix. Second property, if you multiply a matrix A with a scalar k and then you take the transpose, it is same as that you multiply A transpose with k, where k is any constant number. Next is, if you have the sum of two matrices A and B and you take their transpose, so the transpose sign can distribute over addition. So this is equal to A transpose plus B transpose. And the last property is, if you have the product of two matrices A and B, which is AB, and you take the whole transpose, but when you open the bracket, then this becomes reverse. This becomes B transpose into A transpose. This is very important to note, that AB whole transpose is equal to B transpose into A transpose. All these properties can be verified with the questions given in the exercise. Now we discuss symmetric matrix. A square matrix, first of all you have to note down that a symmetric matrix can only be a square matrix. Only a square matrix can be symmetric. So a square matrix A, which is equal to Aij m cross m, it is called symmetric if its transpose is equal to same as A. It means that either you take the transpose of A or you take A, both of them are going to be same. How will it be possible? It will be possible if Aij is equal to Aj. What does it mean? It means that A12 should be equal to A21, A13 should be equal to A31, and A21 should be equal to A12 and A32 and so on should be equal to A23. So and so on. So if these elements are equal, then you call a matrix to be a symmetric. But what about the diagonal elements? So diagonal elements can be anything, they can be any numbers. So let us take one example. If I take a matrix A, this is a square matrix A whose order is 3 by 3, root 3, 2, 3, 2 and so on, 2 minus 1.5 minus 1, 3 minus 1, 1. And if I want to write its transpose, so I read a row, I read the first row, root 3, 2, 3 and write it in first column, root 3, 2, 3. Then I read the second row, which is 2 minus 1.5 minus 1 and write it as second column, 2 minus 1.5 and minus 1. Then I read the third row and write it as third column, that is 3 minus 1 and 1. So now students, please compare the matrix A and the matrix A transpose. Let us compare row wise, root 3, 2, 3, first row same, 2 minus 1.5 minus 1, second row same, 3 minus 1, 1, 3 minus 1, 1. Third row also same. And you saw that I wrote the transpose of A, but still the transpose is coming out to be same as A. That means A is equal to A transpose, or in other words, in other symbol I can write A is equal to A dash. Dash also represents the transpose. What does it mean? It means that its matrix A is a symmetric matrix. Now let us observe some elements. This is element A12 and this is element A21. So I notice that A12 and A21, they are same. Then I notice that this is element A13 and this is element A31, they are also same. This is element A23 and this is element A32, they are also same. So I can write here, let me write it symbolically, A11, 12, 13, 21, 22, 23, A31, 32, 33. So I observe that this element and this element, they are going to be equal. This element and this element, they are going to be equal. This element and this element, they are going to be equal. But diagonal elements may not be equal to each other, may not be equal to any other element, may be equal, may not be equal. There is no restriction on diagonal elements in case of a symmetric matrix. Now we discuss skew symmetric matrix. A square matrix A, Aij m cross m is said to be skew symmetric if its transpose is equal to negative of A. So what was happening in case of symmetric matrix was that A transpose was equal to A. But in case of skew symmetric matrix, A transpose is coming out to be negative of the matrix A. For a skew symmetric matrix, A transpose is negative of A. This means that Aij is equal to minus Aj. So what is Aij, Aj? Let me discuss with you. Consider this matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. So what happens in a skew symmetric matrix is that Aij, Ji means if you interchange the indices, these two elements A12, 21 will be negative of each other. A31 and A13, they will be negative of each other. A32 and A23, they will also be negative of each other. This is the meaning of this sentence, that Aij is equal to negative of Aji. And second thing is Aii is 0. That means A11 will be 0, A22 will be 0 and A33 will be 0. So in a skew symmetric matrix, all the diagonal elements are 0 and all the non-diagonal elements are such that A12 is equal to A21, A13 equal to 31, 23 equal to 32. Let us take one example. Consider this matrix A, 0AB minus A0C minus B minus C0. Let me write its transpose. So to write its transpose, I read the row and write it in a column. So first row here becomes a column 0, A, B. Now I read the second row and write it as second column minus A, 0, C. Now I write third row, I read third row minus B minus C 0 and write it here as third column. Now what I observe is that in this matrix, from this matrix, if I take negative common, what do I get? 0, A, B minus A, 0, C minus B minus C 0, which comes out to be negative common A. So I have observed that in matrix A, if I took its transpose, I got a matrix which was equal to negative of matrix A. That is, A transpose is equal to minus A. So we say that A is a skew symmetric matrix. Now we come to theorem 1. Theorem 1 says that for any square matrix A with real entries, A plus A transpose is symmetric and A minus A transpose is skew symmetric. So let us see how, although the proofs of any theorems are not asked in CBSE exams, but it's a very simple proof. Let us discuss. So we have to first prove that this matrix A plus A transpose, this is a symmetric matrix. So to prove it to be symmetric, I take A plus A transpose and its whole transpose. By using the properties of transpose, I know that transpose sign can be distributed over addition. So this is equal to A transpose plus A transpose transpose. A transpose plus A transpose transpose is A. Again using the properties of transpose, which comes out to be A plus A transpose, because addition is commutative. So I have noticed that A plus A transpose whole transpose is nothing but A plus A transpose. What does it mean? It means that the matrix A plus A transpose is symmetric. Now we discuss theorem 2. Theorem 2 says that every square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. So if A is any square matrix, A can be expressed as the sum of a symmetric and a skew symmetric matrix. So I observe that algebraically I can write A as A plus A dash by 2 plus A minus A dash by 2. You can see A by 2 plus A by 2 will be 1 and A dash by 2 plus A by 2 plus A by 2 will be A, and a dash by 2 minus a dash by 2 will cancel. So actually LHS and RHS are equal. But we have already discussed in theorem 1 that a plus a dash is symmetric. Then a plus a dash upon 2 will also be symmetric. We have already seen that a minus a dash is skew symmetric. So a minus a dash upon 2 will also be skew symmetric. So with this theorem I conclude my today's class, and in my next class I am going to discuss the important and difficult problems of exercise 3.3. So students, be with me, keep watching the videos, and please be serious about your studies. That is the lockdown period and we all are very helpless. We are feeling helpless, but we have to be with our country. So okay.